Well, good morning, everyone here in class and online. My name is Abdulrahman Haikal. I am an instructor at Cal State Long Beach. I teach Geotechnical Engineering lecture and lab classes. It's actually a funny story how I started doing geotech. And every time we start a new class, I ask my students, who in here is interested in geotechnical engineering? And I almost never get any hands raised up. It's not the sexy topic everybody goes for, like transportation or structural engineering, but it is pretty important for the FE, because if you look at the breakdown of the subjects by percentage or by number of questions, you will notice that geotech has the most questions at 9 to 14. So structural is 6 to 9 questions, hydraulics is 8 to 12, you have structural analysis too, that's also a big one, but you have surveying 4 to 6, construction 4 to 6, environmental 6 to 9 questions, transpo 8 to 12, and then you have your geotech once again at 9 to 14. So it is a pretty important subject for the FE and later on the PE exam. So back to my story of how I started geotech. It was probably 10 years ago, recession time, and people were getting fired and not a lot of people were getting hired, if any, at that time. So I was a student, maybe a junior, and when you anticipate something bad happening, you want to over prepare and prepare and prepare. And so I looked at my resume and I said, okay, I have a little bit of internship experience. I have one summer, I have nothing. Other than that, I have just like courses that I have. So how do I look better, when I'm competing with all these people, all this pool that are all competing for the same job? So how do I stand out? And immediately I thought that I had to take the EIT exam. So if I'm a student and I already have the EIT exam and I go for that interview, it's like I have that under my belt, and I look good. So that's what I did. I studied and studied and studied, and I passed the EIT, and I showed up to an interview, and the lady that was interviewing me said, like, are you sure that you're applying for this position? And it was a lab technician position. I mean, it wasn't an engineering track at all, but it was an engineering firm, and I just wanted to get my foot in the door. I was pretty much overqualified with the EIT at that point, and immediately I got the position, even though there were a lot of other people at the time who were qualified in terms of experience, but I had the EIT. They knew that I was on the engineering track, and I got the job, and eventually I started from an intern to a lab tech to a lab manager to an engineer to, when I left, I was on the project management track, and that's when I jumped ship and I moved to the county. But that is how I started. It all started with, I think, in my opinion, my determination to get it's interchangeable, but I'll say EIT because that's what it was called back then. Now it's the FE, but it really started with the FE. So first off, like, I wanted to really commend you for making this decision, and it is an investment for you in your future, just as it was for mine, and it paid off tremendously. So we're here. You're on a Sunday. You could be out with family and friends. I mean, it's gonna be a beautiful day here in Southern California, probably in the 70s. It's a little chilly this morning, but there's a lot of things that you could be doing outside. But now you're in the classroom. I would really make the best of it. Give me your attention, give me your energy, and I will give you the best energy that I have, and I'll help you out as much as I can in these few hours that we have together. So again, when I go into my classroom, I tell students that I'm basically, when I'm teaching geotechnical engineering, I'm pretty much summarizing or giving them the best of, almost 10,000 hours of geotechnical engineering practice that I had working, at the consulting firm that I worked at. So the semester or the quarter is only maybe like 40 or 50 hours. You subtract, like we have Thanksgiving Day, and you subtract uh, the tests, we have exams, we have all that, we have questions. So it's really like, it's a little bit of hours to learn in the course itself. And now what we're doing is we're taking that course and we're summarizing it once again into, the 6 or 7 hour course here. So what I'm trying to say is that this is merely a review. It's an extensive, we're going to make it, thorough to cover the essentials you'll need for the exam. And so it's going to be a fast pace. It's going to have lots of material, and I just want your attention with me for these few hours. And I promise when you take the exam, you're going to remember the things we talked about here in the class, and you're going to breeze through it. Hopefully, and that's a plan. Okay, so let us start. We're going to start with geology, the origin of rock and soil. Okay, we have three main types of rock. We have our igneous, our sedimentary, and our metamorphic. So the igneous rock is from molten magma. It's a rock that's basically melted beneath earth and cools, and it forms the rocks. The second type is the sedimentary rocks that are formed by cementing and compacting different types of soils, and they recrystallize into rock. The third type is metamorphic. This is rock that has transformed, whether through as an igneous or a sedimentary, due to heat or pressure. Why do we care about rocks? So we study about that, in the beginning chapters usually. Well, because soil comes from rock. So if we understand rock, it'll help us better understand soils. So the rock itself goes through two types of weathering to become the soil that we're studying, right? Soil mechanics. So the first type of weathering is the mechanical weathering, and that is due to the physical weathering on the rock itself. Okay, that is due probably like to wind, it falling, igneous, like landslides, it can freeze and thaw, it break off, and then you'll have your coarse grain. This is in general terms what forms our gravels and our sands, and they're mostly our cohesionless particles. And then the other type of weathering is the chemical weathering, and that develops really tiny particles, and that is what tends to form our silts and our clays. They're cohesive, so they're sticky material, though not all of the fine grains do show this cohesive property like some silts. But this chemical weathering is due to acids and salts reacting with minerals. They form small particles, and that is how we get our clay, minerals, and our silts. Okay? What I'm going to try to do is, if you have the FE handout available, the FE review manual that you really should have. If you don't have it, I recommend you go on their website and you download it, because I mean, this is from the test makers. They're giving you the handout, the equations, everything that's going to be there. It's important stuff. So what I want to do, that in conjunction with the outline that NCES has provided, so after that exam specs that I was talking about, let me see which page that's going to be on. Bear with me 1 second. I saw it this morning. I don't know, it disappeared on us. Okay, so let's actually then go to the FE Civil Review Manual, or PPI, and then we can kind of follow that. So we spoke about rocks. We're going to go flip the page, and we're going to start talking about the soil particles themselves. We're going to get right to that. So like we said, soil is an aggregate of loose mineral and organic particles, right? We've all been to the beach and seen the beach sand, or sometimes, in our backyard, sometimes we have clays, after rain, your shoe gets stuck. It's so sticky and cohesive. It's kind of annoying. So you have different types of particles. You have, your nice clean sands, you have your clays, you have the ones mixed up with gravel. So how do we determine what kind of soil we're dealing with? Okay, we're building, let's say, a Costco. Okay, we have this nice piece of land. We're gonna grade it. We're gonna make sure our top layer is nice and compacted. But what kind of soil is there? Because every type of soil needs different kind of attention or design. As an engineer, we really care about that. It's not just dirt. And that is the first thing I tell my students is, from this point on, after taking a geotechnical class, you cannot call soil dirt anymore. Okay, this is, I want you to get to the, no, I'm kidding. I don't want you to classify it when you see it. You're walking on the beach, you're watching the sunset. It's like, oh, this is a poorly graded sand here. It's not like that, but at least call it what it is. It's soil, it's sand, it's clay, it's gravel. So how do we know what is what? And we do that through what's called soil particle size distribution, or grain size analysis, or sieve analysis. It has a few names. And if you've taken the geotechnical lab, this is one of the basic tests that we conduct in the lab. Okay, so the primary components of any soil are gravel, sand, silt, and clay. Okay, and they go in that order. So if you're looking at page 17.3, you'll see that, the size, the 4 inches, 3 inches goes all the way down to 200. What I want you to remember, just 2 of them. So forget all these, and I want you to remember 2. The number 4, not the 4-inch. I want you to remember the number 4 sieve, and I want you to remember the number 200. Those are the most important sieves, and I'll show